everyone, and one good morning to everyone. In previous video, we discussing about some special type of functions such as one-on functions, one-to functions, many-one functions, bijective function, composition functions. Now, in this video, we are discussing about bijective functions. In previous video, I gave you the definition of bijective functions. Now, discussing about bijective function. How can we say the function is bijective? And give the example of bijective function. Bijective functions, suppose f is a function from a to b is said to be bijective. If it is both one and onto. If it is both one and onto. If f satisfies condition of one and onto, then the function is called as bijective function. That means f must satisfy first of all one. That is f of x is equal to f of y. That implies x is equal to y, or f of x1 is equal to f of x2. That implies x1 is equal to x2. Similarly, on 2, that is small y belongs to b and every y belongs to b and x belongs to a. For each and every y belongs to b and every x belongs to set a, the function and f of x is equal to y, then the function is called as bijective functions. Now let us see an example how to test the function is bijective or not. Let us see an example. Let us see the example. So that the function f is mapping from x to y, where x is equal to all real number excluding 2. Because the function defined f of x is equal to x minus 1 by x minus 2, whenever the value of x is equal to 2, the function is not defined. Therefore, x is the domain of the function. So, whenever we put in the value of x in the given function, x is equal to in the given function, the function is not defined. Similarly, we have to test the function is on the y. If y is equal to all real number excluding 1, defined by f of x is equal to x minus 1 by x minus 2, is a bijective function. For bijective function, it is sufficient to show that the function is 1 as well as 1 2. We have to now show that injectivity or 1 test, 1 test. Injectivity or 1 test. 1 test or injectivity. We have to test the function is 1. Okay? For 1 what will do? Given f is mapping from x to y, let x1 and x2 are two elements which belongs to capital X. Now we have to find out f of x1. That means x1 minus 1 by x1 minus 2. Similarly, f of x2. F of x2 will how much? F of x2 will be x2 minus 1 by x2 minus 2. Here, for 1 f of x1 is equal to f of x2. For 1 f of x1 is equal to f of x2. That implies x1 minus 1 by x1 minus 2 is equal to x2 minus 1 by x2 minus 2. Cross multiply, we get x1 x2 plus 2 is equal to x1 x2 plus 2 2 will be cancelled. Therefore x1 x2 is equal to x1 x2. That implies x1 x1 x2 minus x1 into x2 is equal to here 2 will be cancelled, x1 x2 will be cancelled, minus 2 x1 is equal to minus 2 x2. That implies x1 is equal to x2. The function satisfies x1 is equal to x2. So the function is 1. Clear? The function is 1. Now we test the function is onto or not. Test for onto. We have test the function is onto or not. Onto test or subjective. Onto test. For onto test, let f of x is equal to y. That implies y is equal to x minus 1 by x minus 2. Cross multiply x minus 2 into y is equal to x minus 1. Or that implies we get xy minus 2y is equal to x minus 1. Here so xy minus x is equal to 2y minus 1. I am simply taking the common x. Therefore, y minus 1 is equal to 2y minus 1. Therefore, x is equal to 2y minus 1 by y minus 1, where y not equal to 1. Also given y not equal to 1, our real number is excluding y not equal to 1 belongs to y. Hence the function is 1. Hence the function is 1. Or we have to also find out f of 2y minus 1 by y minus 1, which is equal to the result will be y. The result will be y. Hence the function is all the functions satisfy both 1 and 2, so the function is binary. Hence the function is bijective. Hence the function is bijective. Remember, modulus function, signum function, greatest integer functions are not bijective functions. Clear? Modulus function does not one function. Modulus function is not also on 2. Similarly, greatest integer function is not also 1. So these functions are not bijective functions. Now we are discussing about composition of function or function of a function. Composition of function or function of function or function of a function. What is? Suppose let f is a function from set a to, मान लो x is a function from a to. Similarly, and g is a function from set b to g is a function from set b to c. Then the composition function of function from f to g, f and g. Composition function of f and g is denoted as GOF. g of f, that is or defined as, that is g is a function from set A to g is a function from set A to set C. Suppose here set A, let this is our set B, let this is our set C. The diagrammatic representation of the g of the function. Suppose it is consisting the element A containing the element x. Here we get f of x. Now f of x, let this is equal to y. F of x is equal to y. Now we get g of y. What is the value of y? That means f of x, which is equal to g of f of x, which is related to, suppose x is any value in A or any elements of A, we get f of x, which is the element of B. The f of y is the element of or a pre-image of or images of f of x is equal to g of y. We get the relation or function from set A to C. So it is denoted as GOF. GOF is a composition function which is mapping from set A to C via B. Okay. Similarly, also another composition function that is called as hog. Hog of x, that means f of g of x. Similarly, GOF of x is equal to g of f of x is a function from A to C, and this is the function from C to A. Here, remember the note, GOF of any function is not equal to hog of functions. It is only valid or equal for identity functions. Identity function, that means f of x is equal to x, that function is called as identity functions. Now taking an example and define the GOF of the functions. Okay? Let us see the example. Suppose f is a function from a, e, i, o, u set to 1, 2, 3, 4, 5, and g is a function from 1, 2, 3, 4, 5 to 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. Suppose here set A, let this is our set B, and let this is our set C. Taking the diagram, set A, set B, set C. A to B the F relation, and G is the relation from B to C. It is consisting 1, 2, 3, 4, 5. It is containing, it is consisting A, E, I, O, U set of vowels, and 1, 2, 3, 4, 5. It is consisting 1, 1 by 2, 1 by 3, 1 by 4, and 1 by 5, and also 1 by 6. 1 set C containing 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and 1 by 6. Now, suppose A is related to 1 and B is related to 2, I is related to 3, or image of O is 4, image of U is 5. Similarly, image of 1 is 1, image of 2 is half, image of 3 is 1 by 3, image of 4 is 1 by 4, image of 5 is 1 by 5. Here, from A to B, that means f of A will be how much? F of x is equal to y, that means f of A is equal to 1. Similarly, f of B is equal to how much? F of E is equal to how much? 2. F of I is equal to 2. F of O means 4. F of 5 means, F of U means 5. Similarly, G of 1 that is equal to 1, g of 2 that is equal to 1 by 2, g of 3 that is equal to 1 by 3, g of 4 that is equal to 1 by 4, g of 5 that is equal to 1 by 5. Now I have to determine graph of the functions. Graph means, what do you mean by graph? Taking function first in operation in f, then followed by g. That means g of f of x. Here f of x is equal to how much? 8. Then we have to find out g of f of a. That means f of a का वैल्यू क्या है? f of a का वैल्यू 1 है. तो g of 1. Here g of 1 how much? G of 1. G of 1. That means 1. Now the order pair will be how much? Graph order pair will be how much? Now a and 1. A 1. Similarly, graph of E will be how much? The G of f of E. F of E का वैल्यू क्या है? F of E is equal to 2. Therefore, G of 2. F of E is equal to 2. G of 2 will be how much? G of 2. From the figure, G of 2 is equal to half. Now the order pair will be E and half. Continuing in this way, we get the graph. Now finally find out U half, which is graph is a function which is related from set A to C. This is the meaning of graph. Similarly, we find out the form, which is followed. Form means f of g of x. First operation taking in g, then followed by f. That is called as a graph. Now this is the concept of fog and of graph of functions. And let us see an example. We have to find out the fog and the graph of the functions. Suppose f is a function from R to R defined by f of x is equal to s square plus 5, and g is also a function from R to R defined by f of x is equal to sin x. We have to find out graph and form. Graph of x. That means g of find graph of x and form of x. And now g of f of x, that means g of f of x. What is the value of f of x? Now g of f of x, that means s square plus 5. What is the value of g of x? That is equal to sin x. G of x, that is equal to, sorry, it is our g of x. G of x is equal to how much? Sin x. Whenever it is x, then we get x. When it is 2, then it is also 2. When it is 10, it is also 10. When it is y, then it is also y. Therefore, g of s square plus 5, replacing the value of s square plus 5 in the place of x, we get sin s square plus 5. This is the graph of the function. Similarly, we have to find out the form of the functions. Form of the function, that means f of g of x. That means f of g of x means that is equal to sin x. Replacing this value in place of x, we get sin x whole square plus 5. That means sin square x. This is the value of fog and the graph. In this way, we determine the values of graph and fog. I hope everyone understood the video. If any doubt, please contact me. In next video, we will be discussing about inverse of functions. It is a very special and most important topic that is called as inverse of a function. How can we define inverse of a function? For inverse of a function, the function must be bijective. That means it is satisfy one and one two conditions. Okay. In next video we will discuss about inverse of the function.